Today, I'm going to tell you something that you don't hear on TV. And no, possibly, the James Webb telescope will fail. Of course, nobody wants it to fail. It's taken over 20 years to design and build and has cost $10 billion US. Probably the most expensive science experiment ever built. And the James Webb telescope sees nothing. It has no eyepiece and in fact can't see anything out in the universe. How does it work? To understand that, we have to go back to some basic physics of our universe. When we look up at the night sky and we see stars, we're actually only seeing stars in our galaxy, Milky Way, named after some chocolate bar. No, it's a good name. Very few objects up there that you can see with the naked eye are actually outside of our own galaxy. And of course, being mere Earthlings at the bottom of this planet, we're only seeing things in the visible spectrum. And that limits how optical telescopes can see. Telescopes are actually time machines, and the furthest thing away that you can see with the naked eye, or even Hubble, is about 10 billion years old. That's how long optical light has taken to reach our eyes or the telescope. But the universe is much older than that, probably near 14 billion years. So what does the really old stuff look like? Well, you've got a big problem seeing it. The light is so old, it's no longer in the tiny band we see as optical light. It's stretched, it's aged. It's an old person like me. It's long in the tooth and has changed from the lowest frequency of red light we can see into the infrared. Wow. And that ancient light is what the James Webb telescope is designed to look at. It opens up a whole new universe of things you can't see with normal telescopes. It's hopefully going to answer this enormous question of what is the missing period from visible light back towards the Big Bang itself. What do the earliest stars look like? How did galaxies form? All that is beyond our understanding with optical light. And you need to go into longer wavelengths, infrared, microwaves, and of course my favorite subject, radio telescopes. They're all ways of looking further back in time. So I really hope it works, but I'm going to tell you something now that the James Webb team don't talk about very much. And that's the two most likely failure modes. The issue with the James Webb is it's going to be so far away, you can't go up and fix it. Unlike Hubble, which has been fixed multiple times, James Webb is millions of miles away. You switch it on and it just has to work and keep working. Although they only plan to work for about 5 years with a possible extended lifetime of 10. So it's a super expensive experiment. But how could it break? Well, the most dangerous thing that can happen to the James Webb Space Telescope is it doesn't get there. The rocket fails, it goes to the wrong place. And there's nothing you can really do about that apart from put it on top of one of the best rockets in the world. Not a rocket made by a car manufacturer or somebody who sells you packages in the post, but a rocket made in Europe, an Ariane rocket, and they're pretty good. So it's going to be launched by an ESA, European Space Agency, Ariane rocket. Yes, I hope it works. But then there's a big problem. The second most likely failure mode is sadly its parasol, its heat shield, which is the size of a tennis court, doesn't open. And it needs this parasol underneath it to shield it from our sun. It's still relatively close to our star, and it has to block all the infrared radiation from the sun to its instruments. And the temperature difference from the dark side of the shield to the bright side is about 500 degrees Celsius. Now, to make something 500 Celsius as a shield, it's a big sheet of metal, but they're going to build the shield out of mylar. You know, the stuff that the Roswell anyway, mylar, thin metallized plastic, 5 layers of it that are going to pop out, unfurl and stretch into a tennis court sized shield. But here's the big problem. In fact, 108 big problems. The mylar tennis court shield has latches, little automated solenoid valves that let go of the 5 layers of mylar, bang, 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 over 100 of them. And the James Webb people say they all 100% have to work. Good luck with that. Who's ever tried to put a duvet cover on? So if it did go wrong, what could they do? Well, they've thought about this, and this is really amusing and simple. If the 108 latches fail to work, they can turn them off and turn them on again. That's probably going to fix it if they can't reverse the polarity. I'm joking. And the second thing they can do is to shake the entire telescope. So if something gets stuck, they can vibrate it and hopefully, boing, the parasol will deploy. And there's a third thing. If they all fail, turning them off and turning them on again and shaking still hasn't made it work, they can put the whole telescope into spin mode and run it round and round and round, and hopefully, whoop, it will come out. I hope that doesn't happen. And now I have to tell you a story about you, the viewers. So you might have watched a recent update I did to how you communicate with submarines, and I didn't know the answer to the mystery. And you know I have this catchphrase, the truth is out there. Okay, it's a bit conspiratorial, it's a bit X-Filesy, but it's not exactly what I mean. I mean that the truth really is out there. I've worked in TV all my life, and it's all full of experts who tell you stuff. But the internet and YouTube is different. You know your stuff, putting it politely. So I got the answer. Somebody who works for the US Navy told me why they don't use ELF anymore, and I'm going to tell you. And it's pretty simple. ELF was slow, ultra slow, sending a message, and unreliable. They really had to reliably say launch or don't launch the missiles, and it was a lot of interference, and they couldn't get rid of it. VLF, although it can be blocked, is actually more stable. But that's not the secret thing he told me. What he said was, sure, we still use VLF because it's actually quite reliable, but all we send on the VLF waveband is one message, and that is, don't launch the missiles, we're not at war. So there's a constant everything's okay signal, possibly in the form of a green light, and then they can change the signal to amber alert, or even red alert with Klingons attacking the starboard bow. Oh no, you know, whatever, you get ready to launch your missiles. But the VLF just sends a constant tone, which illuminates the world is not at war. Stand down. And they don't use it for anything else. It's too slow and too rubbish. What they do use now is space-based satellite assets. I don't know how they work. Maybe lasers, maybe some kind of antenna which can be nearly surfaced by a submarine and communicate with a satellite, and areas of the seabed where they can pick up their email, or however it works. I've even heard that they use acoustic messages. Poor whales. But isn't that marvelous? somebody watches one of my films where I'm asking for help because I know the truth is out there, and they answer the question. And that's what makes my channel unique from television. It's interactive. And the best thing I ever did was started a Patreon Science Club account. There's over 500 Patreons, and I asked them all the same question. What are you an expert in? What are your interests? What industry have you worked in all your life? And we all swap ideas. When you join, I'll ask you what your interests and skills are, and I'll give you my personal email address so we can talk about stuff, new ideas for films, and swap ideas. So come and add your private and secret knowledge and skills to my Patreon account. You're really going to enjoy it, and you'll learn, just like me, first, why the US Navy cancelled the ELF program. Because of you, the truth is out there.